Okay, so good evening. So I'm going to put the recording on so that you have an idea lah. Okay, so basically that's me. So for my part, I will only be focusing on topic 5, 6, 7 for this module. Okay, the DESIS. Mr. Chan already covered topic 1 to 4, right? Okay, so that's me. We will look at topic 5 of your notes. Okay, which will cover, these are the things that will be touched on. Okay, now for me, mainly we will be very focused on the sensor part. The sensor part as well as the converter, filter also, yes. And also the DAC, ADC, analog to digital converter, or digital to analog converter, and some filters as well. So this will be my area, okay, that we will be talking about. So your exam will be 4 questions, but next week is your common test, by the way. Okay, next week will be your common test, so please study for your common test. Okay. Now, so without further ado, okay, these are the things. Now, as an intro, very quick intro. This module is very relevant because sensors, as you know, are very important. They are used from a wide range of application. Nowadays, I think you see a lot of this in the market. I don't have to say. You've seen all these things. These are more military operation. Last time I worked for MINDEF. I worked for DSO National Lab. So we were doing a research project about defense related. If you all know what's torpedo, you all know what's torpedo? Yes, okay, correct. So you all know torpedo. So we do those kind of project. Torpedo countermeasure project for torpedo. Okay. So last time, quite a few years already. Now the Navy has acquired a fleet of submarine, the S class. So then they need support to do those kind of weapon stuff. Yeah, so we were doing those torpedo. Okay, but anyway, that was my earlier part of my career before I joined Ngee Ann. So we're doing the defense. Okay, so now moving on. So sensors, I think you can see there are many different sensors. So in this topic 5, okay, we will be focusing on the different type of sensor, okay, and how we can use them. Yeah, so a lot of things that you can see over here, okay, chemical sensor, wide range of sensor that are being used. Right, so from even taking your glucose, right, to find out the blood sugar level, okay, to even an MRI machine, okay, used in the hospital and so on. Okay, now technology quite advanced, a lot very high resolution imaging, can do a lot of things, very powerful. Now a lot of words here, you all have the notes, right? You all can try to just follow lah. Okay, but this is just introduction, so it will be very light to begin with. The introduction part is very light, just to give you a flavor and overview that actually sensor is being used very widely. Okay, I teach this also for my day class. Okay, where we in the lab, you all use the lab view, right? That's how you all were at the lab. You all use the software lab view for data acquisition and so on. So that one is a very, very powerful tool. Okay, the company that created this software lab view is a company called National Instruments. National Instruments is a very big company in US. I visited them sometime in August in US, and they have branches all over the world. And they are specializing in this data acquisition, measurement, and sensor technology. All right. So a general block for this sensor measurement system will look something like this. In a very simple block diagram, you have blocks. These are called block diagrams. So the lowest level will be the sensing element over here, as you can see. So things will be like your temperature sensor. Any of you use 4 to 20 milliamp sensor at your workplace? Any of you work with strain gauge, maybe? Load cell, anybody? Maybe, depend. I don't know what industry you all come from. Anybody in the oil and gas? Any oil and gas? No? I know one guy not here today, Schneider, right? One of the guy not here. Schneider, okay, so Schneider also has its own proprietary technology. So, and I'm not sure what industry you're from, okay, but certainly sensor is used a lot, very widely. Even now, the ICA, the immigration checkpoint, along Woodland, Tuas, the border, right? They even deploy sensor now to protect the border. You know, those fence, right? You maybe have seen before. The fence, they scared the people can climb up the fence, right? Now they even put those sensors, so they can differentiate whether a monkey is climbing on the fence or a human climbing on the fence. They know. Okay. The other one, of course, is the Istana, or the Istana place, right, in Singapore, near the Dhoby Ghaut area, right? The Istana, if you see carefully, around the fence, so-called, is all put along this like a netting, right? It's all sensor. So they can differentiate whether a monkey is on top of it or a human trying to climb up to get over the fence. So they are smart enough. Okay? So they can be able to do that. So you need the simplest level is the sensing element. So you need sensor. What kind of sensor? Well, there are many. We can talk about it. Okay, ranging from resistive sensor, capacitive sensor, inductive, and so on and so forth. Many. Okay? So the next block will be signal conditioning. It will be like amplifiers. Right? Because the signal from the sensor is very low. So typically you need to boost up the signal, right? Or maybe you need to filter. Okay, something like that. All right. Now there are many different signal conditioning. For us in this module, we will learn about filters, which I think you all may have learned some idea already. Right? Some first order filter, low pass, band pass, high pass filter, basic kind of things. Okay. Then of course we need to process signal and so on. So there are quite a range of things that we do. All the way to when you show your data on the screen, right? Like what you all do in the lab. You all use the software lab view, you display the thermometer reading, right? Up to the kind of level. So from very front end, you collect data all the way until you display the data. Because otherwise the data must make the operator or the user see the data, then they do something about it. Okay? So now these are the very typical kind of structure that you will see, or block diagram, which you can find in your notes. I don't need to copy. Okay, it's in your notes. Now, anybody know what does this diagram show you? No? Of course they say already lah. But have you all seen it before? Yeah, now they say you're correct. All the longkang here, all everywhere, those drainage. Remember some time ago, Orchard Road got flood. Remember Orchard Road? NEA, kena scold, right? What happened? Longkang flood, Orchard Road flood. A bit of embarrassment there, right? So what it's trying to do here is the system here. Now there's this company, they are doing quite well. I think they deploy a lot of, they probably get the contract, NEA contract. Yeah, one company, you can see their logo. Okay, so basically what they do, they install the solar panel. Then they have sensor put at the water level, basically, to monitor the water level. You can find this along the market only, just outside. Further down, near the opposite the hawker center. Okay, so for early warning nowadays a lot. Okay, early warning system. Now they also solar panel now very cheap. They put a lot of these things. They put a CC camera, right? CCTV small camera there, right? To monitor the road condition, right? Very cheap. Now they deploy a lot of these things here. Okay, even I saw it on Malaysia also. I went to Malaysia over the weekend, along the highway. No, I went to my family to bring my daughter, my wife with the school we went to Dizaru. Also we see many of these kind of system. You all here must start very excited. You recorded. Okay. All right. Yeah, so this kind of system very common. Malaysia I see also now. Along the highway I can see quite a few of these being deployed. Okay, everywhere because the price has come down significantly. Solar to charge the battery so that you can sustain a long period of time. So it is unmanned, low maintenance. Yeah. I think they have this thing called days of autonomy. That means the battery can run with, even if it's cloudy, right? They can run at least 3 days, 3 to 3.5 days.
Yeah, because the battery 100 Ah,
depend on the AH. If you bigger, of course, can last longer. But you take a long time to charge also. Okay? So depends. All right? Now, so basically, I'm going to skip this one first. Now, what I'm trying to show you here is the use of sensor, data acquisition, and using, for example, the VI. The VI stuff that we did in the lab, right? Hey, by the way, your practical test is based on the lab 4. It's the stuff that you have to do the lab view, put the temperature thing, and then using the blue color, the demo unit.
Sir, the lab sheet you returned to us.
I brought it today. For my class only, by the way. These are the, for my lab group, so you can find your, take away. Okay. So please try to get back your lab sheet from Mr. Chan, if you are in the other class. Yeah. Okay, so looking at time, now is 8:30. Okay. Now, so basically, there are some terminologies. Now, in your exam, we may ask you some to define some terms, but that one only very low marks, not a lot of marks. For example, I might ask you a short one statement. What is a transducer? Explain. Okay, exam. While you're here, exam, suddenly the ears and eyes all open. Okay, so for example, a question, short question, 3 marks maybe. What is a transducer? Explain. Okay, now so basically, now this is just a definition. Okay, now a sensor, maybe start with sensor, but it's simpler. Sensor is just the lowest, what do you call it, the simplest device that converts, right? For example, if you say temperature sensor will convert, for example, degree Celsius, right? In this room, for example, degree Celsius to electrical voltage, so that you can measure the electrical voltage, right? That's the only way you can measure. You can measure voltage, you can measure current, you can measure resistance, you can measure other things. Okay, but generally you convert that physical parameter, which is temperature in degrees Celsius, that we so commonly know, convert temperature into a voltage, electrical signal, so that we can measure that. Okay, being electrical engineer, right, we need to measure signal. And what kind of signal? Voltage, current. Okay, these are the very 2 common ones. So it converts these into some kind of an electrical signal where we can measure. Now, transducer is slightly a little bit different, but I'd like to show you the next diagram here. Do you have this on your slide, on your notes? I think you have, right? Yeah, this picture here, transducer, is a slightly just an additional thing for what we call a transducer. So you all use 4 to 20, you heard about 4 to 20 milliamp transducer? 4 to 20 milliamp, current one, current loop. Some may have used before, you all maybe shy, don't want to say. Okay, but anyway, because what is the problem with using sensor that is voltage output? What is the problem? If I measure, can I go long distance or not? Let's say if I want to measure, I want to plant a sensor, maybe at, you all know where is Makan Place, right? You all know where is Makan Place? Where you all normally go for makan before you all come class? Oh, yeah. Food club, okay. Food club, right? Say you go food club, right? Now let's say from here to food club, roughly how far? Make an estimate. How far here to food club? Distance. 300 meter, okay, 300 meter. Okay, let's say 300 meter, fine. Now let's say I want to know what is the temperature now in that food court now. Food club, block 22, right? So if you put a sensor there, right, but how is it going to relay that temperature to me until here? So we say 300 meter, right? So if I put a temperature sensor, the output is electrical voltage. What happens if I pull cable, pull until there, then you pull until here, what happens? Of course, let's say the output for the sensor, poor sensor output only 2 to 3 volts. By the time it come all the way here, finish, the voltage gone. Why? Why is that? Because wires, cables, right, got resistance. So resistor means the voltage drop. So by the time you drop until here, nothing, you got nothing left. So useless, right? So they're not accurate already. No, cannot also. You will have error, and the error propagate. Okay, so the idea is to, why don't we use current loop, which is what I'm trying to explain. So what happened is that at the sensor there, you will convert it into electrical current. That's why we call it 4 to 20 milliamp. Okay, that current loop can transmit from there until here, long distance. Because current won't have drop, where got voltage drop? Huh? Current loop. Correct, for analog. So you run a current loop, you can lay the trunking cable, you can run it all the way here. Maybe along the way you need a repeater, but it's still okay. So you will run a current loop. This is called a transducer. Basically what it does is that sensor here output voltage, right? But you convert the voltage into current before you transmit out. So it's called a transducer because it converts. Okay, there's a variable conversion element here. Okay, 4 to 20, very common. Tell you, very, very common. We do a lot of projects. Last time we do project for the MRT. We lay those transducer along the track to measure temperature. Every 50 meter we take a temperature reading. So the track very long. Okay, so that kind of thing Okay. Right, so the transducer basically is an additional, is a combination of just the sensor along with some conversion element. So it's called a transducer. Give you some idea. All right. Yeah, okay, so this is just a picture or image to show you that let's say, you know what's a thermocouple? Thermocouple you all use? No, thermocouple is for measuring what? Temperature. Okay, it's a kind of a sensor. Okay, so you use the thermocouple, okay, but alone itself you can't do very much because the signal may be very small. So you need to amplify. Okay, amplify the signal before you can do further processing. Right. So other things like any of you in the automotive industry doing with cars? Any of you? No. So we also do projects for myself. I do a lot of projects, both in consultancy to the industry, and also a lot of our FYP project students. We do a lot of projects. I also work with Panasonic. They also work on those automotive projects for cars. The cars, in-car stereo system. Okay, and those kind of stuff. All right, so we use a lot of sensor like pressure to measure the pressure in the car. Car is very interesting. A lot of very sophisticated. The car itself, there are at least easily about 70, 80 microcontroller in the car. Every part they take care of different things. Some take care of the engine control, ECU, engine control unit. Some take care of the braking system and airbag system. All different things, all have one microcontroller. So even to the point, let's say the part that deploy the airbag, right, also got one microcontroller just to take care of that part. Okay, and then there are other things. Okay, so quite interesting. Yeah, so if you can see that, let's say a car, if a car don't have sensor, the car not very useful. Right or not? Now very advanced, right? Your car got reverse sensor, everything. Your engine light up, overheat, you also can see. Because there's a sensor constantly monitoring your vehicle. Okay, and so on. Now I'd like to introduce to you these two terms. Sometimes they're being asked in the exam before. Maybe you want to take note. This one. Take note. Okay. Take note. Okay, what is, okay. Huh? Quiz. I got one quiz, but the one later. I will tell you one, don't worry. I will roughly scope things for you, for your exam kind of thing. So you all must listen along the way. Okay, now this thing called passive and active. What is the difference? Of course, I know you can read there, but let me share with you. What do you mean by active sensor? Okay, then there's one called passive. Active means anything that is active requires power supply. Okay, now maybe to tell you what is passive. Passive means not you have, for example, resistive sensor. That one no need power in a way. You no need to externally power it. Yeah, thermocouple, yes, good example. You don't need extra power or stimulus to the thing to make it work. On itself, it works in a way. Like piezoelectric. You know what's piezoelectric sensor? Sensor where you step on it, right? You will generate electrical voltage by itself, naturally, because of the physical property. That means if I press on this thing, they will generate electrical voltage. Okay, so if you keep pressing on it, then the thing will keep generate electric. Yes, kind of. So it's called like piezoelectric, for example. So it basically is a passive one. It will generate its own signal. Yes. Correct. Okay, something that is passive. Resistive sensor is a very good example. Okay, we will see more later. Okay, so active sensor are things like, for example, thermistor and other things that you need external power to power up the device before it works. Right? So these are the common questions. What is the difference, or explain what is an active sensor? Okay, maybe you can take that. Or what is a passive sensor? Explain. Okay, 3 marks kind of question, short question. Okay, so you can find this thing. Now, quite recently there was a incident, right? It was reported in the news. There was this lady who stayed in a HDB flat, right? His hand got severed off by the lift. The lift, yeah. You know what happened? I think you all read about it. The sensor cannot sense, because what happened was the case was, and they found, I think BCA found that, BCA, the building construction, was it, I can't remember which authority. They found that it was not the fault of the lift itself. So hang but the manufacturer or the installer, the contractor, vendor for the thing, hang jialat, kena sue until, you know what happened. What happened was, the lady was leashing a dog. You know those leash, right? Those kind of not very solid, the one you can imagine can cut off the whole hand. What happened was, I think she was trying to bring the dog for a walk, and then I think going home or something. So the dog, when the door closed, the dog dashed out. So the string was attached to the dog, right? Okay, but the hand, I think because he looked around, then the lift closed. Usually you would think that the lift will, because sensor, right, will open. But it was found that because the sensor cannot detect that kind of thin resolution, because the leash, the dog leash, the wire, I think it's very solid, very thin. So the sensor cannot detect, then the door closed, then it went up. So you can imagine, very scary, very terrible. The whole hand ripped off.
But the dog never died.
The dog didn't die, is it?
Never died.
Oh, I didn't know. But very jialat, very scary. The whole hand got this torn out. Yeah, scary, very scary. Yeah, but I mean, yeah, okay, but it's talk about, I mean, just trying to draw that to some this kind of context here where we have sensors, those door, okay, when you use on-off contact sensors, probably one of these, okay, when you just detect like a limit switch or some kind of a contact. Of course, there could be other more sensitive sensors, photo sensor and so on. Okay, but too bad that incident, because the wire, the leash dog thing is too thin. Okay, and then it's probably very, very tough. The one inside, I think you don't know what kind of material inside. Probably some, fishing line also can cut off your hand. Right now, they can catch a fish. They can cast a net, catch a marlin. Those big marlin fish. You can imagine the thing won't snap. Your hand will gone. No joy. No joy. Okay. Yeah. Okay. Now let's go on and talk a little bit about the different types of classification. Classification. This is for reference. For reference, you can see. So you can take note of my stuff there. I put maybe not shown. But is it shown? There's a word reference there for your info. Okay, now different ways to classify sensor. Okay, the one later part. Now, beginning part, a bit of like introduction, kind of like words, quite a lot of words. The calculation part is later, okay, where you will need. But these are some short, good to know kind of question, okay, for your reference. Different type of sensor, which I'm not going to go through all, but generally, we'll be looking at things like temperature sensor, okay, very common one. Temperature sensor, pressure sensor, and so on. Okay, now these are the different characteristics just for your reference again. Now your sensor can be from very cheap, few cents, to few $1,000s, okay, or tens of thousands. Okay, for example, in the airport, right, the Changi airport or some of the airports around the world, they have this thermal camera. Those are fluke or some FLIR. Okay, FLIR thermal camera. That means you pass by, they can scan without measuring you, they know your temperature. You all seen before? Those kind of thermal imaging. They use a lot in the US, those Apache helicopter, Singapore also. The Apache helicopter got those thermal FLIR camera. They fly night vision, they can see. Okay, night vision, okay, because it's a thermal sensing. So few $100,000 those camera. Okay, so from very cheap local to very, very high end. Generally, you look at all these things. So for sensor, when you want to classify sensor, okay, reliability, military grade, of course, is a military type of technology. Okay, the operating life and so on. These are some of the characteristics. Okay, so for example, let's say we want to measure the engine ECU, car engine. Okay, what kind of sensor we use, for example. So you have to consider these things. Okay, if you use for very, very rugged, very harsh type of environment, right now, let's say thermal cycling means that, for example, you put your sensor, let's say I want to put it at the a chemical plant, maybe chemical plant, those kind of what do you call that, silo, big kind of tank, right? Rain and shine under every single day. So temperature, the thermal cycling, every day under the hot sun, 12 noon, the temperature very high, 40, 50 degrees. Then at night, very cold. Okay, so there is different transition, high, very hot, then cold, very hot, then cold, or even desert. Okay, there's this thing called thermal cycling. Your sensor can take it, you put there, or after 3 days finish, spoil already. Okay, so it depends, you see. So it depends on the condition. Of course, military one is those military grade, is very high specs, very high specification. All right. So now the performance of sensor, this one just to take note. Okay, you have this thing like a black box. To me, the sensor is like a black box. Okay, I stands for input, O for output. That means I know. Let's say for example, I have a sensor. My temperature sensor, I always use temperature sensor as an example. It's the simplest one. So I know that this sensor, right, it has a certain range. Right, it can measure maybe say, I don't know, maybe 0 degree until 80 degrees, for example. So this is the input. So the output will be electrical voltage, for example. Maybe only output from say 0 to maybe 10 volts. Okay, so this is the input, this is the output. So the input is the temperature. Output is electrical voltage. Okay, then you can characterize it. Okay, now these are some of the terms quite important. This one maybe you should take note. All of you, this one quite important. Yeah, there, important. Okay, please take note of this one. This one is very important. And coming closer here, the camera can see. Okay, this camera that is recording. Okay, so basically, by the way, why I'm wearing this, because this one is a microphone. This thing is tracking this fella, not really tracking me. Of course, it tracks me because I'm inside. I'm wearing this because this is a microphone. That's why the sound is creeps. Because I'm speaking directly to it, and the thing is Bluetooth to the device. Okay, so this is important. The performance of the characteristics of sensor for the sensor itself. I'm sure you know what's a range. Everything has a range, max, minimum, maximum, minimum that you can measure. Okay. Right now, no, you cannot just buy anything off the shelf and then just plug it and use it, because you must know what is the requirement. Always gather what is your requirement first. Okay, in the application, design application, you must know what are you measuring. What is the kind of range you are looking at. So we talk about range. Is it for normal ambient room temperature measurement, or is it out in the field, in the jungle or in the desert? There's always the totally different ball game, right? Because you need to know what's the range. What is the resolution? Resolution means what is the smallest detectable change you can measure. Is it in you all learned the Mr. Chan's part, right? Remember he talked about the 3.5 digit DMM. What kind of range are we talking about? Is it 300 millivolt or are you talking about the 300 volts? So that kind of range is different, right? Of course, the smaller the range, the resolution will be better lah. Smaller resolution is good. That means you can measure more finer details. Okay, resolution. Okay, now I'll be talking about what is the difference between accuracy and precision later. I got this bull's eye chart which I'll show you. What is the difference? What do you mean by accuracy? Okay, then what's the meaning of precision? Okay, and so on. So these are some of the terms that you might want to take note. Okay, probably likely like short question kind of thing will come out. Okay, so yeah. Okay, let's show you what is this next thing. Okay, now this one, okay, for reference. Okay, we often need to calibrate the sensor. Okay, calibrate the sensor. So we know what is the input, what is the output. Usually we want to work with linear system. So O stands for output, I stands for input. So let's say, for example, just now I say, right, let's say I have the temperature sensor here, the input will be the temperature. The output here will be electrical voltage. So I need to know what is the relationship between these two. So very likely we like to use linear system if possible. But if cannot, then no choice. We will go for other types where we need to calibrate the sensor first. Okay. So then we talk about the things like sensitivity. Sensitivity means it's the gradient, the slope. We talk about how sensitive this thing is. Whether does it change very rapidly or not. Okay, we talk about output versus the input. So the slope is the sensitivity, K. Okay, for your reference. Now linear, as I say, we like things to be linear as much as we can. Okay, linear sensors is easier. It makes life easier when you do the calibration. And then it's easier to use as well. Okay, now there are different types. This one is just for your reference also. Different type, how you calibrate. Okay, then you know what's offset. For example, maybe they are offset. Okay, not zero. For example, will be like your bathroom weighing scale. You know, the weighing scale that we have at home. Sometimes it's not accurate, right? Because it's not zero centered. So before you hop onto it, so what do you normally do? You will look at it first, right? You will try to zero adjust, zero base. You want to zero calibrate it, so that when you hop on it, then you will not have any offset. Okay, standard lah. It's kind of common sense. Okay, so these are some of the things that we will think about when we deal with sensor. Okay, now linear one. Okay, for example, okay, it's an equation of a straight line. Linear is the best. Okay, so what is an example here? Just an example to share with you. You can take a look at this example later yourself. Okay, what it does is that it says that, hey, you have this resistive sensor, okay, that is used to measure temperature. So basically the resistance changes when the temperature changes. Okay, so you can see that usually an equation will be given to you like this, a simple linear equation, where M is the sensitivity, which is the slope. Okay, so let's say you need to find out what is the M, for example. You are given the upper limit, lower limit. You calculate what is the slope. And then after that, after you calculate the slope, you can put everything back. Okay, so R0 is the y-intercept and so on. So you can get a simple linear equation. Okay, so that after you form this equation, for any temperature given to you, right, you can plug in to get the resistor value, for example. Okay, so it can be very useful. Okay, this one you also can refer. Now things like transfer function, this one also in the notes. Let's say I want to know, let's say for example over here, every 0.2 degrees Celsius change, what is the voltage? We need to know those kind of small little details. Yep. Okay, so this is another one. Let's say it says that particular transducer has a certain transfer function. So it's like us telling you that one is the sensitivity, the slope. Transfer function also means it's the sensitivity, the slope. So let's say, for example, here, then they ask you, okay, if you measure a 412 millivolt, what is the output? For example, what is the equivalent the temperature for this voltage that you measure? What is the temperature? Okay, so you can see that you just do a straight division. Very clear cut. Take a straight division where you take the millivolt divide by this sensitivity. Yeah, you will get the temperature. Okay, now besides that, this one for reference, for reference only, because unless you do a university degree course, this one they can go into very deep. Okay, they talk about what are the, we also need to consider, for example, environmental effects. Let's say you put a sensor there, doesn't mean that you put it there, you work all the way, you are very happy. But what happens, there's temperature fluctuation. Your sensor also be affected, you know. You have temperature change, right? Your sensor may also vary, you know. You can see this thing here. Okay, what happens, there's a drift. The signal, your voltage output drift because of temperature effect. Temperature is a big headache sometimes, especially those doing design one. Yeah, when you design something, you need to consider temperature. What happens, the temperature increase, your sensor will change the behavior. No? Okay, so imagine those who design the NASA, you know, the space agency, US, the space agency, they put the satellite in space. Okay, but bearing in mind that the satellite may work on planet, okay, under our planet condition, right? But once you launch a satellite to space, in the orbit, different, you know, it's a different ball game altogether. But why? Because when you're up there, the temperature is closer to sun. So what happens? Maybe the temperature may change, right? Maybe higher or something like that, right? And then the environment also different. Now it's vacuum up there, but here Earth is another. You know what I mean? So it's a different. You see, so you must consider all these things. But of course, we're not saying that we're going to design something for the space, but something to let you think about and be aware. Okay. So resolution means, we always say what's the resolution means, what is the smallest you can measure, smallest quantity that you can measure, okay? Now hysteresis, I'm not going to cover, this one for reference. I want to go straight to the last part here on this one, accuracy. I'll talk about these two, accuracy and precision. What is the difference? What's the difference between these two? Okay, now accuracy, I will give you a very concrete example. For those, what is the difference between accuracy, what is precision? Okay, now I think some of us went through military training, right? Some of us, some don't, right? You know, in army, right, you have to go for range. Range means shooting. For male, I mean, mostly, because now we have a lot of international students also, international, so some may not know what we're talking about. So if you go for guys in Singapore, we need to do national service. So it means we are full-time army for, now last time was 30 months, 2.5 years. Now I think become 2 years. So 2.5 years we have to serve army. So in army, we go through basic military training where we use rifle, shoot. How to shoot target, right? Okay, now let me show you this example. There's a difference between accuracy and precision. Now this chart will explain to you very clearly. Okay, now you tell me, right? Now imagine this is what I call the bullseye chart. Any of you play darts? Last time we all play, army time we play darts. You know those board? You take a few darts, right? Usually 5, right? You take, then you whack, you hit the thing. You try to hit the bullseye, right? This part here. The closer you are, the more points you get, right? But the further away, you lose points. The scoring system is like that, right? The inner part, highest point. And then the thing goes out. Maybe 80, then 60, then something like that. Okay? Now, do you think this one is... Okay, later, because I haven't explained what is precision and accuracy, right? Now look at this. You tell me, this one, is it accurate or not? Okay, you're right. Because accurate means I want to hit the bullseye. I call it the bullseye. I want to hit this part. So is this accurate? Lousy, right? Because this one is low and low. Because you are not accurate. You see, that's why accuracy. Yeah lah, correct lah. Here's an example. L means low, accuracy very low. H means high, good, high accuracy. Now this one is low because you never hit the bullseye. Bullseye, I mean as in spot on, never hit. Not really. So I would say the accuracy quite low. This one. Now precision means what? What is precision? But what is it lah? I explain. I know it's precise, but what is it? What is precise? Consistency. That means precise means I'm able to hit the target always around there. Okay, an example here. This is an example. Now this one is not accurate though, because it didn't hit the bullseye, right? Accuracy is low, but it's very precise. High precision is high because it's able to so-called hit at the same spot. Okay, this one is bobo shooter. I think we all know. Army, we all say this guy bobo shooter. Shoot everywhere. Everywhere. Spray only. Anyhow spray. Shoot everywhere. This one at least not too bad. Can got kill. This one is precise because it's able to hit the one spot. This one must do zeroing. This guy. The weapon must do zeroing probably. Never must bring this thing to here. You know what I mean? Rifle must do zeroing. This one is precision. You understand? This one precision very high because same spot. You're able to concentrate on one area. Hood the same area. Whack this part. Same area, but accuracy low lah. Accuracy low because never hit this spot. This one of course is the best. Okay, you understand? This one high accuracy, high precision. This one good. Hood the same spot. Okay, I say okay, high accuracy, high precision, always on one area. Okay, is it clear? I think this one has to explain a lot. Easier, of course you can. Yeah, you can go and read this one. What is this explaining this one? I think simple, easy to understand. You can think about it.
More simple is.
Simple.
Those people who precise but not accurate.
Okay, so question may be, okay, explain what is precision. Okay, one typical kind of thing. Okay, maybe you ask, okay, or maybe we change, what is accuracy? Explain your own words. Yeah, explain. You can draw a chart like this and explain. What are these? Yeah, some students draw this and explain. But we accept because we know that you understand.
Precision is consistent.
Which one?
Consistent precision.
ABC.
Be like consistent.
This one, the precision is good.
Can you put consistent?
Can consistent. Can we accept? Consistent reading. Okay, consistent reading, consistent measurement. It's fine. Okay? Can Okay. So yeah, just another interpretation, another representation of the same thing. Okay, important. This one. Typically, we like to ask you, what is the difference between these two? Yeah. Okay, important. Take note. Some. A lot of reference, don't you see? Quite a lot of reference. For your reference, just to take note. Okay. Yeah. So precision also something to do with repeatability, able to repeat. Able to repeat the better. Okay, now I'm just going to quickly touch on this one for the, say, an error, for example here. Now, FS stands for full scale. By the way, you want to take down, take note. FS means full scale. Full scale. Full. Scale as the SCALE. Full scale. FS. The next one. Now, which one has a smaller error? For this one, I know you all got answer, right? You all got answer? No. Okay, which one? Full scale. Full scale means the maximum. When I say, what is the full scale? Means it's the maximum. Full scale at the top of the ceiling, maximum. Full scale. That's the meaning. FS stands for full scale. Full scale means maximum. Okay? Now, you have two different pressure transducers, for example. So, it says that an error, that means you have an error plus minus 1% of the full scale. It's a bit like a resistor, Your resistor got tolerance, right? Plus, minus, kind of thing, right? Same thing. Every transducer is not perfect. Okay, it has a certain range and there's a certain tolerance you can allow. So usually it's a very small percentage. Okay, so in this case, since 1% of the full scale for a transducer B, right? B has a range. By the way, pressure you measure in bars. Maybe you all may not know. Pressure is measured in bars. Okay, so it's a unit. It's a unit. Or PSI. Okay. A few others, but just an example. We use bar. How many bars? Barometer, they call it. Those barometer or something. Okay, but anyway, just an example. So 1% of 5 bars is only 0.05. The other one is 1% of 10, right? So which one would have a smaller error? Yeah, of course. This one got a smaller error, but also smaller error, but it has a smaller range also, half the size only. Because the A has between 0 to 10, it can measure wider range, right? Where B only can measure from 0 to 5. It's only correct. Depend on, again, is how many range you want. What kind of, that's why again it depends on what you want, you see. Depend on your design. What do you want to measure? What are you trying to do? So then you choose the component or your sensor accordingly. What you want? You want accuracy, or you want what? What do you want? You want higher, smaller error, or you want bigger range? It's always a trade-off. It's a trade-off, right? Trade-off means you gain something, you have to lose something. Trade-off, they call it, trade-off. Okay? Now this one I think you can skip. This one you can skip. They're not covered. This one you can skip. Okay. Now these are just an overview. This diagram here just to show you an overview of the different types of signal conditioning. But of course, as I say, if you want to go into this one, you can even study a degree in this area, right? Especially like you want to do oil and gas. Yeah, I got friends who now like doing those oil and gas one. Wow, very good. Earn big money. You all know. Those in oil and gas one. Wow, they are those plant engineer, those kind of thing. Shell or those, how the company. I think quite a few. Last time I got a friend who have to travel to oil rig. Every week you have to take chopper, fly to don't know where, then land on the helipad, stay there for 2-3 days, then after that come back. Yeah, I think in Brunei or something. Those I can't remember. Yeah, quite a few Shell and yeah, correct. Right? Good money. Their bonus, damn good. Very powerful. Bonus what? No, not in that. Not really. Not quite into those. No, not really. Those are different. Those are no, those study chemical engineering will be good. Huh? No, not so much. Got so much. No, great. Not so much. I think. Okay. Yeah, so basically for us, I think this one is just an overview, just to share with you. Okay. Okay, this one maybe I will also move on. Hey, you all seen before, no? This kind of thing. Where do you all see this kind of thing? You all know? Okay. You all okay, correct. What you all normally see? You all have this kind of, this is called the bridge, right? They call it the bridge. But what is it for? Bridge. This kind of thing. What is it? You all? Okay, good. Okay, one example, but not for this case. But you're right. It's this one is like if you think about it, it's like a full bridge rectifier. Okay, you're right to say that it converts AC into DC, right? Right. Full. This but this is slightly different over here. We are using this to do some measurement. Okay, so you're right to say. Okay, it's like a full bridge rectifier. Full bridge. Found in the power supply. All power supply have this one. Convert AC, right? AC means 230 to DC. Then after you do other things. You need to filter, regulate, and so on. Okay, but we use bridge sometimes for application where we do some measurement. Okay, this one maybe later on we will explain. Okay, so something like this. For example, I have over here, let's say you have 4 resistors, for example. Usually they are using for strain gauge. Strain gauge means they measure the force, the pressure. Okay, let's say if I want to measure 2 person, I want to know, like those amusement park. The good old days when you play, the children come, they take one of those kind of like dummy hammer, right? They will whack this thing, right? Boom. Then this will rise out, right? The level, right? How high can you go, right? You know what I mean? Those kind of game. Okay, so basically that one is a piezoelectric sense or strain gauge if you like. So this thing when you hit it, right, depending on how hard you exert the force onto this sensor, right, it will change the resistance. Okay, maybe the harder you hit, the higher the resistance or something like this. Okay, so what happened is that how do you measure that resistance? Okay, so they put a bridge, called a Wheatstone bridge. This is also called a Wheatstone bridge. WHEAT. Wheatstone bridge. Oh, this time round, this one important. I must tell you, because we exam paper we set already. Okay, this one is called a Wheatstone bridge. I'm talking about exam. This one. Okay, this is called a Wheatstone bridge. Yeah, I will explain a bit later when we look at using capacitive sensor. That one later part. But just to share with you first, this is called a Wheatstone bridge. Now how it works is this. Now you see there are 4 resistors, right? Okay, so I know that if they are balanced, what do you mean by balance? You all know? When we say balance, what does it mean? When I say balance, you all take down the code already. Yeah, okay. So what do you mean by balance? Say for example, maybe good to explain. I think I don't need the light. Okay. Now let's say for example here, right? Now you can see over here. Also, I'm not very good at drawing. So you have to pardon my sketch. This is just a sketch. Okay, now what happened is this. Okay, you have, let's say for example, R1, R2. Now, if I say, hey, these 4 resistor value are the same, what is the voltage here? We all know. 4 resistors, same value. Maybe let's say all 1K. Let's say for example, what is the voltage here? Okay, if I supply, the voltage can be anything. It can be anything. What is the voltage here? Maybe 5 volts or whatever. 10 also can. What is the voltage here? If it's balanced, all the same resistor. What is the voltage here? When we call balance. Balance means the resistors are all the same value. That means R1 resistor value equals to 1K, 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 1K. What is the voltage here? Let's say I call it point A and point B. These 2 points. What is the voltage? Is it 5? Are you sure? 5. Now, first thing first, try to think about it. This is like a voltage divider, right? Voltage divider. You all know what's a voltage divider? I want to find this voltage here. What do I do? Let's say here. What do I do? I want to find this voltage here. So I take R2 over R1 plus R2, right? Times the supply voltage. Okay? Because they are the same resistor, right? Let's say 1K over 1K plus 1K, right? If you remember, voltage divider rule. R2 over R1 plus R2, right? Times the supply. Let's say times the E. Okay, this one is R1, R2. So this one is like R1. This one is R1 plus R2. So it will be half, right? Because 1K over 2K is half what? So half times the supply, say 5 volt is 2.5 volts. Let's say for example. Now same likewise here will be the same also. Because it's a balance, because the resistor same value. So here also let's say 2.5. So what is the difference between these 2 points? 0. Very good. Because it will be balanced. Only when it's balanced, the voltage across here will be 0 volt. Under balance condition. You understand what I mean? Balance condition. But how the, sorry, question? Somebody asked something. Okay, so if it's balanced, right, now what can we do with this bridge? So now after I calibrate, let's say if I'm going to change, let's say I know that, okay, I'm going to use 1K, right? Now then later on, I'm going to make this one a variable. Okay, now imagine now I put a strain gauge here. A strain gauge basically is a sensor that measures force. So when you exert a force onto it, right, the resistance change value. Okay, change value. So that means if let's say if I make this one a variable, right, I put a strain gauge. I put a strain gauge. Okay, I put a strain gauge here. That means now I first of all balance it first. I balance it. I put a strain gauge here, a component that is maybe close to this resistor value. The other three I don't touch. I leave it. Okay, so imagine now if this thing is balanced, that means if I never exert a force onto it, what is the output voltage here? 0, yes. Okay, because it's balanced. And I choose this component close to these three values, 1K for example. Now then I go and press onto it. Imagine I go and hit it, right? So what happens when I hit it? The resistance change. Right? Now when your resistance change, maybe this one no longer 1K. It's going to change, right? Okay, so maybe now this one become the strain gauge. Your 1K here is actually one of these value here, right? This value. Maybe now increase to 1.2K, for example, right? This one. So what happens to the voltage here? Will it be 0 now? No more already, right? It will be disturbed already, right? This bridge will be disturbed because the voltage changed already. Now no longer 2.5. It's been disturbed. Now, not to worry, we will do a more detailed analysis of this one later, in the later part, okay? Not to worry, just give you a flavor, give you a rough idea, okay? So when you disturb this thing, the temperature no longer 2.5, it changed. So that means the difference here and here will be different already, you know what I mean? The voltage changed already. So I know that when you change the voltage, I know you have something, you have a force, something somewhere, okay, exerted onto the strain gauge. Okay, just an example, just an example. Any question so far? This one? Yes, they measure the force. Yeah, they measure the force, okay, on maybe the train track. Okay, the train track. They want to measure the rate of change. Okay, but that's one. That's one activity. There are many different sensors they can do from laser to, and so on. Okay, this is one possibility. Yeah, okay, so we are just trying to tell you that, hey, this one, when it's not balanced, okay, something happened, there's a voltage. Okay, now the last slide, last two more slides. I think we'll call it an evening. So for signal conditioning, there are many different types. Because the signal may be too small, where we require amplification, we need to amplify, or we can filter. Okay, different type. When there are noise, we filter the signal. Okay, now one example will be to tell us, there are noise also, different types of noise, and so on. So we need filtering and so on. Okay. Now I think this one for your reference, because Mr. Chan has done quite a lot with you already, this one. Right, the measuring the signal to noise, this one I think you all cover, right? The ratio. When it's voltage, you use 20 log. When it's power, you use 10. Okay, I think you all know, voltage, it use 20. Okay, signal to noise. If you want power, then you take 10. Okay, this one for my case, I'm not going to test you this. Just tell you. I won't be testing you because Mr. Chan already tested you. I just put it as a reference. Okay. Okay, I think I'll stop here. Getting quite a lot. We'll stop here. Okay. Yeah, quite heavy. First lesson. Okay, we pause here.